Hi, everybody. I am Anissa Tanweer. I'm the program director for the UW Data Science for Social Good program. And this is an information session for folks who are considering submitting a project proposal to become a project lead in our program. Yesterday, we had an information session for students who are thinking of applying to our program to become student fellows. So if you happen to be here and that is actually your situation, then we will be posting a recording of that tutorial to our website within the week. So if you're a student and thinking of applying to become a full-time student fellow, that information session would have some specific information that's relevant to you. You're welcome to stay for this one as well. There's just some information is different. So with that, we'll go ahead and get started. I will be, let me give you the agenda here. So I'll provide just a really quick introduction to what the eScience Institute does. The eScience Institute is the home of the Data Science for Social Good program. And then I'll tell you a little bit about the Data Science for Social Good program itself and sort of the motivation behind it, why we do the program. And then I'll turn it over to Mark Weldon-Smith, our program manager, who will tell you about the program structure and shape and kind of what you can expect the program to look like on a day-to-day basis. And then he'll hand it back to me and I will talk a little bit about the project selection process and what you can expect as you move through that process and what we're looking for, and tell you a bit about previous projects that we've taken on in the past. So you have a sense of kind of the breadth of our interests and what we're looking for. So with that, as I said, the eScience Institute is the parent organization for the UW Data Science for Social Good program. And we're a hub for data-intensive science on the campus of the University of Washington. Our mission is to empower researchers and students in all fields to answer fundamental questions through the use of large, complex, and/or noisy data. And we have been around for 15 years now. We just had our 15-year celebration in November, and the DSSG program has been running for 9 of those years. So this will be our 10th iteration, which is a really exciting milestone for us. This is our physical home on campus. We're housed on the 6th floor of the Physics and Astronomy Tower. If you happen to be familiar with campus, that's a photo of our building you see there on the left. And it's an open, it's a mixed use open office floor plan. So we have a lot of different kinds of spaces within the studio. We have some rooms that can be used in sort of traditional seminar style configurations, a nice big conference room, little breakout rooms that can be used for remote work or quiet conversations. And then a lot of informal spaces, comfortable couches, a kitchen, and lots of whiteboard space for collaboration. This is a slide showing the members of our research staff. And what I mostly want to draw your attention to here is our disciplinary breadth. And so I like to joke that we literally have disciplines from A to Z represented. We have an astrophysicist on staff as well as a zoologist. So we really take that intellectual breadth and intellectual diversity seriously here, and is one of the really cool things about working in this space, I think. So this is just a list of some of our other core programs, the ways that we disseminate data science expertise and best practices. So we have open office hours that are available to anybody on campus, whether that's students, faculty, research scientists, whatever it may be. We offer a data science seminar every quarter for credit for students. At the beginning of every quarter, we also run software carpentry, which is a quick 4-day boot camp that serves as an introduction to programming. And usually we offer both Python and R. We also have a whole suite of more disciplinary oriented hack weeks. And we run an incubator program every winter that pairs one of our data scientists with a researcher to do kind of intensive work. They commit to working together 16 hours a week for the entire quarter to really push hard and advance some aspect of that researcher's work. And then we have the Data Science for Social Good program, which is what you are all here to find out about. So in this program, we have kind of multiple goals that we're trying to meet simultaneously. I think the first and most important thing to realize is that, with the name Data Science for Social Good, that's sort of aspirational. We realize that, having good intentions are just the beginning when it comes to generating positive social incomes or outcomes. And so we incorporate a lot of time for ethical discussion and reflection and for considering the impact of the work from a lot of different angles. So we really try to see the program as a laboratory where we're trying to figure out how to use data science for social good. And we approach that as a really layered and complex undertaking. Equally important to that goal is training the students who are fellows in the program and training them in data science methods and best practices. So we really try to be very responsive to students' interests and needs, and we get a lot of feedback from the fellows at various points in the program, and then we're continually using that to iterate and update and make changes every year that reflect what the fellows most need to get the most out of the program. We're also very interested in increasing data science capacity across various fields, disciplines, partner organizations, and different kinds of researchers. And so that's kind of, affecting the organizational capacities of the organizations that our project leads come from. And then, of course, we're aiming to positively impact society in the subject areas that are taken up by the projects that we support in the program. So those are four of the major goals that we're trying to hit all at once here. And then Mark will tell you a little bit more about how we go about that, what the shape and the structure of the program is and what you can expect. Oh, sorry, I forgot to mention that we added this slide just to let you know. A couple years ago, we also produced this white paper called the Data for Good Growth Map. So we took what we've learned from running our program for many years and also connected with 16 other institutions who run similar programs, similar in some ways. All of our programs have slightly different flavors and structures and orientations. But we got together and created this growth map that lays out some decision points that an institution would need to take into consideration, the sort of options that it has when developing a program like this. So if you are coming from a university that doesn't have a program like this and you think it's something that you might be interested in spinning up there, this would be a really good starting point and a good resource. And we're also always available to answer any questions and help guide that process as well. So now, for real, I will turn it over to Mark to talk about program structure.
Thank you, Anissa. I'm Mark Weldon-Smith. I'm the Program Manager for Community Engagement with the eScience Institute and the Program Manager for the DSSG program. Anissa's graciously going to forward the slides for me. We're actually in different locations today as I go through this. I just want to let you know that if you have any questions, there is a Q&A button. It seems like some of the guests have found that. We will be having a Q&A section at the end, but if any questions come up for you while we're talking, feel free to put them in the window there and we'll address them at the end. But yeah, let me just talk through the team composition for the program to give you an overview of the team structure. So our program is organized around teams, and in 2024, we intend to have 4 teams with the following structure. It's 4 student fellows, 1 eScience data science lead, and 1 to 2 project leads. By design, we look to build student fellow cohorts around disciplinary diversity with a range of technical skills. And we try to balance the interests of the students with the needs of the actual project. As a program, we support teams through guidance on a number of areas. So these include technical and methodological choices, cloud computing, tool selection, analytical approaches, programming help, and sometimes help with project management. Finally, a note for the project leads, they should be thought, we think of you as co-producers and collaborators rather than clients per se. You're here to help guide the project design and steer overall goals. And, we acknowledge that you come from a range of different technical backgrounds and industries, and we'll talk a little more about what this role entails a little more in the presentation. So we work with project leads from many different disciplines and sectors. As you can see represented on the screen here, we have examples from local Seattle government agencies, other University of Washington departments, and other nonprofit organizations such as the Bill and Melinda Gates Foundation and Conservation International. We're open to industry partnerships as well, although that hasn't been something that we've explored thus far in the DSSG program, but we're very much open to it. Let's talk briefly about the attendance expectations and, for the students that we have, and the three takeaways from this slide are: we expect the student fellows to be there in person in Seattle for the duration of the program. There is some flexibility they have around attendance, but for the project leads and the data science supporting the project, they may be in a variety of modes. They may be on campus, you might be remote, you may be hybrid, depending on the project and on your physical location and availability. Program staff such as Anissa and myself, we will be hybrid. I mean, we are based in Seattle, meaning that sometimes we'll be in the office and sometimes we'll be telecommuting that day, but we will be in Seattle for the duration during the summer. So project leads, what do you get from being involved in this program? So intensive work, this is the most obvious thing, but the projects facilitate a lot of hands and brains devoted to advancing your specific work or area of interest. You gain exposure to new methods and approaches. We want this to be a learning experience, not only for the student fellows, but for you as well. It's an interdisciplinary team. This is the cornerstone of the DSSG program structure. As you can imagine, this can be challenging undertaking, but it's also fun. Networking opportunities are also part of the experience. Long-term collaborations have come out of projects in the past. And of course, publicity. Reporters have come to events and written about the project and posted updates on social media. We're mindful to walk a fine line between sharing project updates and protecting sensitivities related to any data sets that might be need a degree of privacy. This three-pillar structure we have on this slide demonstrates our integrated program structure. So we have a socially impactful data science programs, and this requires of us equal attention to these three areas: applied research, engineering, and ethical engagement practices. And during the 10-week program, each of these pillars inform and provide structure to our process. For a deeper look at these, we suggest exploring our website. Many of you may have found this already. There will be a link later on flashing up on the screen where if you want to jump into the website, if you haven't had a chance to explore it, you'll be able to see some of this information there fleshed out and how we tie it to the 10-week program. So we provide a number of trainings to get everyone up to speed on some of the skills that will be crucial during the program. And here's a list of tutorials that we've offered in the past. The first two are start items. These beginner get and intermediate get, and we always offer these. Other tutorials are provided as needed, depending on what is required in the projects and on student interest. And sometimes we offer tutorials because students request them, even if it's not based on a skill or a tool that will be directly used in their project. We want the teams to feel supported and be successful in all aspects of the program. And, to this end, we run a series of workshops that are discussion-based and interactive, especially in the first 2 weeks. These include areas such as team development, stakeholder engagement and analysis, and public speaking. So we really want the teams, the student fellows, to feel confident moving forward through the program, and giving them some of that initial team bonding and skill sets is an important part of the onboarding process. Student fellows will also engage in things such as project spotlights. These are opportunities for teams to present work on a regular basis. Also a great chance to get feedback for the teams from people outside of the team structure. We undertake regular documentation. It's a cornerstone of data science best practice. As everyone knows, it's important, but it's also hard to make time for. So we intentionally build this into the program. We offer career conversations for the participants. These are panel discussions over provided lunch. We have presentations from professionals engaged in data science for social good that encompass many different sectors. And we also facilitate a couple of social events. So example of these would be ice cream socials or weekly game sessions and karaoke, keeping in mind that students are coming, some of these fellows are not all just UW centric, they're coming from all over the country and many haven't met each other before. So really trying to create that social glue that engenders a positive team building experience. This slide gives you a sense of the program cadence from June 10th through August 16th. So starting at week 1 with team formation, this involves some of the team building activities we touched on earlier, and then moving into weeks 2 through 5, where teams really dig in on the problem space that they'll be working on. Weeks 6 to 7 are about scoping solutions that work within the available project time, through to weeks 8 through 9, which we refer to as grind time. This is where teams will be really pushing hard to deliver on their previously scoped solutions, hoping to stick the landing for week 10, which is the presentation, posting, and handoff time. So that is, in a nutshell, is kind of the flow of the 10 weeks. Again, the website is a great resource for kind of seeing the detail within each of those brackets that you see on the screen there to get a sense of what we cover in terms of materials and tutorials. So what we expect from project leads involved with the DSSG program. So as you can see here, running scoping meetings, we expect to convene at least 2 or 3 of these, but it can be more if the project leads and the data scientists think it's necessary. The ability to work alongside the students assigned to your team for 16 hours. Now, 16 hours, we want to make clear, is kind of a mix of ambient and direct collaboration. So being generally available or maybe directly collaborating, not necessarily 16 dedicated hours of collaboration. So whether this occurs on campus or in virtual spaces may depend on your circumstances and your location. The schedule is flexible and worked out with the team, but expect more commitments during the first 2 weeks of the program. Participation in program-wide meetings, these include workshops, weekly check-ins, spotlight meetings, and leadership meetings. We ask you to bring your domain expertise, so students won't be well-versed in the problem space, and we're relying on the project leads to help them understand the problem they'll be engaging with. Stakeholder engagement, which is a really important part of the program. We, as the eScience Institute, will help with the nuts and bolts of how to do that. And we have some colleagues that are fabulous in giving some guidance on that. But we need you to be the connector and plan the meetings and help bring the students along, although they will also be a part of stakeholder engagement. So ability to discuss work, we mentioned this earlier, we can be very mindful of sensitivities, but we cannot take on projects that are in stealth mode. So there has to be a degree of openness and ability for us to talk about the program on our website. Open and reproducible when at all possible, as the code will be in GitHub. If there's a compelling reason for an exception to this, then please discuss it with us in advance. We're looking to post a description of the project on our website. Some of you may have already been on our website and seen that we have the previous programs and projects that we've run in the last 9 years. All of them are listed on the website to give you a sense of the depth and breadth of the types of projects we've undertaken. And Anissa will talk a little bit more about that later. And an acknowledgement of projects and publications. So we really want the student fellows to be listed as authors on the project and to get that experience. On a side note, project leads are welcome to participate in the tutorials. And finally, we don't require you to have technical skills, but it can be hard to sustain a project after the summer if that's not there. So we just want to say that up front, and that's something you should consider. So DSSG attracts really strong applicants from all over the country, and it's a very competitive process with around 150 to 200 applicants per year. And the program is, as we've mentioned, is a full-time commitment for the students. It's from June 10th through August 16th in Seattle, and we offer a stipend for them to participate. So these applicants must be a current student enrolled during spring and fall 2024, either a grad student or an undergraduate senior entering graduate school in the fall. And when we're assessing the suitability of these student fellows to participate in the program, we tend to prioritize the following. We're looking for a baseline literacy in programming and or quantitative methods, their underlying motivation for applying and ensuring that they're there for the right reasons. We assess this through their personal statements and submissions and through an interview process, which they'll go through. We're looking for a mix of strengths and background. We're looking to build a team, as we've kind of mentioned before, that's going to complement each other as they work on the projects. And finally, their willingness to be a team player and work collaboratively, which is the essence of our program. Lastly, they must be eligible to work in the US. So what you can expect from us as the eScience Institute and the organizers of this program, you'll be supported by data science mentors who are experienced in cross-disciplinary collaboration and have a wide range of expertise in areas such as machine learning, database design, modeling, visualization, statistical inference, GIS, optimization, and cloud computing. And teams will be trained on best practices in version control, reproducibility, ethics, and human-centered design. We also provide a lot of support and structure for teamwork collaboration, which is really the crux of our program and an intensive experience. So as mentioned on the workshop slide, and to help ensure that the teamwork is successful, we begin with a team development workshop at the beginning of the summer. Each team will also complete a project charter to help facilitate conversations for aligning expectations at the start of the program. And we'll intentionally have teams, give teams a periodic reminder to revisit those expectations and align with those goals. We also provide a data science curriculum. The project work is where teams will spend most of their time, but especially in the early weeks of summer, we provide a number of trainings to get everyone up to speed on some of the skills that will be crucial to carry them through the program. So to recap, just 4 quick key takeaway points from my section before I hand it back to Anissa. We really have a thoughtful and intentional program that we've honed and improved and iterated on over our 9 years. And we really bring together a diverse group of student fellows, data scientists, and project leads to collaborate. The teamwork is at the heart of what we do in the program. And we're really looking for participants who are ready to apply themselves in a sustained and collaborative setting. I encourage you to look at our website, particularly our FAQs. It has a lot of in-depth answers to questions that you might have, and for a deeper dive on the program specifics. We'll show the date on the last slide, but just a reminder that the application deadline is February 20, and Anissa's contact details will also be listed at the end. So with that being said, I'm going to pass it back to Anissa now to run through a little bit on the project selection process.
Yeah, so if you're all here, then you have probably seen our call for proposals somewhere. So you know that that process is underway, and we're currently accepting applications. As Mark said, we have a ton of information on our website about the program. We have a tiny URL here, tinyurl.com/UWDSSG. I won't go into, line by line what we ask for in the application, as you can look at it yourselves. But I will say we try to keep the proposal process fairly lightweight. It definitely will take time and thought and care to complete, but it's not like writing a typical grant application to NSF or something like that. And we really see the application as sort of the beginning of a conversation. So the projects that seem like they have potential, we would then request a follow-up conversation and pose questions that came up when we were reviewing the proposal. So it's really, the proposal isn't the only thing that we take into consideration. It's, like I said, it's sort of the beginning of a conversation to find projects that are going to be the right fit for our program. Having said that, you don't have to wait until you submit the proposal to start that conversation. We really encourage folks to reach out to us and have a conversation in advance while you're getting your proposal ready. We want to get strong proposals that are, addressing the questions that we have and giving us the information that we need to make a determination whether there's potential there or not. So we're happy to talk about things in advance. You can reach out directly to me. I can I can answer a lot of questions and kind of get a sense of general fit. For more technically oriented questions, I might steer you to one of our data scientists. I'm not a data scientist myself. I'm a qualitative researcher, but our data science staff is always on hand and happy to answer any questions and have conversations, especially through our office hours mechanism. So you can feel free to look at the office hours website is listed here. See if who fits a description of what you're looking for, what you're proposing, and reach out to them directly, or you can reach out to me and I can point you in the right direction to somebody on the data science side of things. With that, what we're broadly looking for when we're evaluating these proposals is a strong argument for how the project is going to lead to positive social impact. So some people would maybe call this a theory of change, but how this project makes a difference, what the problem is that you're trying to address, and how this project is intervening on that in some way. Solid research and solid methods being proposed. It's really important that the project leads are available and committed to spending time working with our DSSG teams, as Mark has already gone over. Teamwork is a really important part of this experience, and we consider the project leads to be a part of the team, not a client that's outside the program that we're just handing something off to at the end. We are looking for clarity and shovel readiness, by which we largely mean the data needs to be in hand. In 10 weeks goes really fast. It's a very intensive program. So we've just found that in that 10 weeks, it's not really feasible to collect or generate data and do some kind of analysis on it. So we're really looking for projects where the data is already available. And one thing we consider is whether there's a capacity for measurable outcomes, although we also realize in a lot of cases and the nature of the projects that we're taking on, if they're addressing some, long-standing and really thorny social problem, that those metrics of success can be really hard to come by, or that it takes a long time to show what success means. But to the extent that you can articulate for us what you consider to be success and what outcomes you're looking for, that is very favorably viewed. And we're looking for the possibility of sustained engagement. And what I mean by that is that the project, that this is a problem space that project leads have some history and background in, that it's not a one-off where they're working on it for 10 weeks and then it will get shelved or die on the vine. But we're hoping to work with project partners and project leads who are really invested in the problem space, where they're bringing something to us that is part of a longer standing trajectory in their work, where we can make meaningful difference in this short 10-week program. There are a few things that we don't do because we're not really set up to support these with the structure and the expertise that we have on hand at the eScience Institute. Every year we get some proposals that are proposing projects in these spaces and are really valid and wonderful projects that are important and going to make a difference in the world, but just aren't really aligned with the kinds of support that we're positioned to provide as the eScience Institute. So that's things like building data portals that are web-based, doing app development as a primary goal. Sometimes there's some lightweight app development that gets that's done kind of along the way to some other project goal. So for example, the students will sometimes create like shiny apps in R. But that's usually not the primary, building a stable app that many people can use is not really a part of the program. That's something that we can support. And as I mentioned before, the data kind of needs to be in hand. We don't really have the capacity to do data collection as part of the program. This is a very non-exhaustive list of some of the topics that we're interested in taking on that is mostly based on projects that we've done in the past. We're definitely open to working in other areas, but in the past we've done a number of projects related to affordability and livability, city planning, environmental issues, equity and justice, hazards and resilience, health and wellness, housing, public education, sociodemographic disparities, and transportation. These are some of the areas of eScience technical expertise. So areas where we feel eScience is really poised to make a difference in the projects that we take on. So projects that would really benefit from new platforms, algorithms, methods, and data sets. Projects that involve working with large heterogeneous and noisy data sets, scalable analytics and predictive models, interactive visualization, code review, publishing and reproducibility, online teaching materials and tools. Mark talked a bit already about the program structure. This is sort of giving you a sense of what kinds of events in particular we're asking project leads to participate in. So as Mark mentioned, before the program even starts, once your project is selected for the program, then the project lead and the data scientist will meet in advance to have what we call scoping meetings. That's really to, get everything set up so that you can hit the ground running when you have 4 students that are ready to work on your project full-time for the summer. So it's sort of deciding what a tentative deliverable schedule is, what the kind of the first couple weeks of work, what the students are going to do to get them oriented to the project, what seminal papers do they need to read, for example, and getting, considering what kind of software environment you're going to need to be working in and what can be done on the front end to get that set up for the students. We also have a project lead orientation, where we just do a little bit of a deeper dive into kind of what to expect. And we often have data scientists and project leads who have participated in the program in the past come back and talk about their experiences and help give you a sense of, to prepare you for the experience and help you get the most out of it. In the first 2 weeks of the program, the first 2 weeks are really onboarding, getting the teams to gel, getting everybody up to speed on the knowledge and skills that they need to be successful for the rest of the program. As Mark mentioned, we have this, our general rule of thumb is that the project lead commitment is about 16 hours a week on average throughout the summer. In the first week, it might be a little bit more of that. There's a number of activities that we really need everybody in the program to be able to participate in. Again, because we're building a cohort and we're really getting the teams to meet and gel. And that first week is really crucial. So we also are, asking for some flexibility in your scheduling. While for most of the week, you get to determine your own schedule with your teams and what works best for everybody. In that first week, we really need some flexibility from everybody so that we can schedule these, all hands sort of activities that everybody participates in. Your fellows will be involved in quite a few tutorials as well in the first week or 2 of the program. And project leads are always more than welcome to attend those as well. So if there's ever anything that that you see that piques your curiosity or is a skill or a tool that you're interested in learning, you can attend any of those that you want to. So that's kind of the front-loaded first 2 weeks. For the rest of the summer, it's largely project work. And as we've said, that schedule is kind of determined within the teams. But there are a number of touch points for everybody in the program gets together for throughout the week. So we have these project spotlights where the student fellows take turns presenting their work on a regular basis. and getting feedback from people outside of their teams. There are regularly scheduled team check-ins, and we as program organizers do one-on-one check-ins with all of the fellows, each fellow every week, and we highly recommend that project leads do the same with their team members. We also have every other week, we'll have a program leadership check-in. So that will be the program administrators like myself and Mark, and the project leads and the data scientists, so that we can get together and catch any issues that may be coming up, problem solve, share information about what's working well on our team, so that other people can learn from those experiences. There will be occasional tutorials sprinkled in throughout the summer as things come up that fellows participate in. And again, project leads are welcome to if they want to. And what we've been referring to as stakeholder engagement is really important. It's a really, really crucial part of the projects. And we find that, that when students are having these conversations and meetings and doing observations or whatever it may be of their various stakeholders at work, it really changes how they think about their projects and how they and how meaningful the work is, and can shape the project in really interesting and sometimes surprising ways. And so that's something that, we're really leaning on the project leads to help us make those connections with their existing relationships, or sometimes the DSSG program is also an opportunity to expand those the relationships with that set of stakeholders. And then at the end of the summer, we have final presentations and a reception that is sort of just celebrating everything that the teams have accomplished. Some important dates to remember. So our call for proposals has been open since January 3rd. Today is the information session. We've mentioned a few times that the due date for proposals is February 20th. And then by early March, project leads will be informed whether or not they are kind of advancing onto our short list of projects that we're considering. So at that point, there would be, at least one follow-up conversation to clarify any questions that came up when we were reviewing proposals. Around April is when we will be, or sometime towards the end of April is when we'll be deciding what the student fellow cohort looks like. And that will, at that point, we should know which projects we're taking on in the program, and we'll share the descriptions of the projects with the students who were shortlisted as candidates. And then they'll give us some feedback on which projects they're most interested in working on, and why, what they feel they could contribute to that team, and what they want to learn from being a part of it. And then we take that into consideration when finalizing the cohort selection, and trying to find the best fit and the best possible team to work on each project. Anywhere from March to June 10th, when the program begins, is when you can expect to have a series of meetings with the data scientists to scope the project and get ready for the summer to start. June 10th is the first day of the program. It's early this year. It feels early to me. I always think of it as mid-June, but June 10th sounds like early June to me. So, but that's good. That also means that we'll be finishing up a little bit earlier than usual. So August 16th is the last day of the program. And I should also mention, I guess it didn't come up anywhere else here, that, we talked about the first 2 weeks of the program being really critical for onboarding and team formation, and just getting everybody set up for success for the rest of the summer. And the last 2 weeks, of course, are really busy with, meeting deadlines and wrapping up the work and getting it handed off. So we really have an attendance policy where we expect that nobody will miss any time in the first 2 weeks or the last 2 weeks of the program. And then in between there, we know that people will have travel and have to be away for a few days at a time or whatever we may be, and we can accommodate that. But we really need everybody to be present the first 2 weeks and the last 2 weeks. Okay, so I also wanted to just give you a sense of some of the projects we've worked on in the past, so that you can develop a sense of mostly how broadly we think of data science. So I'll start with the projects that we took on last year. The first one was called Generating Regionally Integrative Data Sets to Understand Groundwater Insecurities in the Colorado River Basin. We affectionately just refer to that as the Groundwater Project, since that actual title is a little bit of a mouthful. And that project was premised on the idea that groundwater is really currently poorly understood, in spite of the fact that it's a very important resource for agriculture, for drinking water, for all kinds of things. It's very hard to measure and know what is going on underground and how much water is available. And so the team would often say, refer to the adage, you can't manage what you can't understand. And so they were using data from satellites that detect very minor changes in Earth's gravitational field. And then they would estimate changes in groundwater levels based on those gravitational differences. And what they were really focused on was building a reproducible pipeline that then other water scientists and policy researchers could use to ask further questions of that data. Our second project was looking at the possibility for heat pumps to be used as a heating source for buildings in Alaska and in colder Arctic regions in general. So that was based on the idea that electrification is an important step in fighting climate change and decarbonization. So they were looking at the case of this very challenging environment to use that kind of technology because of the cold temperatures in Alaska. And so what that team did was build a model using statewide building outlines and very granular climate data. And then they created an interactive visualization dashboard that could be tailored to different stakeholder groups who are working in the area of decarbonization in the Arctic. So those are the projects we worked on last year. And then to, give you further insight into this broad view that we have of what counts as data science, I thought I'd talk about a few more that date even further back. And these projects, that what I want to give you a sense of is that there are many different places, many different points in the sort of whole pipeline or life cycle of a data science project where our program can kind of meaningfully make a difference. So this project was using text mining and machine learning on reviews of food. So a kind of previously untapped data source for that purpose, to see if they could detect foodborne illness earlier than more conventional epidemiological methods could do it. And so this was very kind of exploratory work on the front end of a brand new applied research area. Another project we took on, this is an example of one that was where we're kind of entering more at the midpoint and driving one small piece forward of a much larger project with a lot of moving parts. So this was, we were collaborating with a team of researchers from the Taskar Center for Accessible Technology here at the University of Washington. And they had started out by trying to create a routing application that would be tailored to people with mobility limitations, such as people who use wheelchairs to get around. And what they found was that, writing the algorithm to do that routing is the easy part. The hard part is that there's not a lot of good data about the pedestrian environment. And so a bigger and more challenging aspect of their work became figuring out how to populate the map with relevant data. And so this was the project that we took on was part of the Global Open Sidewalks project. And essentially one summer, our team spent that, did a lot of work to develop a proposal for new data standards in OpenStreetMap for how to generate pedestrian data in the pedestrian layer. And so this is a big sprawling project. Like I said, there's a lot of moving parts there. That team is working on it to this day and working on taking some of their solutions to a national scale. And that was, I think, in 2016 that we took on that project. So, it's a there can be a very long-term, big and unwieldy project where we're kind of inserting ourselves into just a small slice of that. And then in contrast, we sometimes take on projects that are at a much later stage of work and more in the refinement phase. And so this would be an example of that, detection of vote dilution. It was we were working with a team of researchers who already had an existing R package called EI Compare that was used to detect vote dilution in minority communities and being used in court cases that were litigating alleged violation of the Voting Rights Act. And so what our students were doing was adding functionality to that and polish and building out a series of vignettes and documentation to make that statistical package more useful to stakeholders who might be interested in using it. See if we can advance. Okay, so that was giving you a sense of kind of the different points of intervention where a project can come into play. But so there was like the more early exploratory work, making a difference on a small slice of a much larger ongoing project. And then there's kind of refining something that's in later stages of development. But our projects also vary quite a bit in terms of the kinds of outputs or artifacts that are being produced. And so this is just an example of what some of those outputs can look like. And I'm not going to go into detail about each of these kind of exemplary projects, but just, generally speaking, sometimes we're creating decision support tools. Other times we're doing something that's more of a proof of concept analysis. Sometimes we're helping to establish responsible or reproducible workflows. Other times we're building out the infrastructural components of a data science project. Sometimes we're focused on democratizing data science and analytics by creating, robust documentation and instructive tools that kind of sit on top of existing software. And sometimes we're developing artifacts that help the public better understand or engage with data-intensive technologies. So what I hope all of that gives you a sense of is just that, there's no one cookie cutter project model. We really take a very broad view of what counts as data science. So it's definitely not just predictive analytics or machine learning or AI. Every project is really unique and it has its own unique set of challenges and opportunities as well. So that is all the content that Mark and I had for you. Hopefully it gives you a sense of what we're looking for and what you can expect from the program. And we are very happy to take questions. I believe that since this is set up as a webinar, you might have to just type your questions, but it does look like you can raise your hand. So we might be able to unmute.
Oh, yes, there is an allow to talk option here. So if anyone wants to raise their hand, I'm happy to monitor the chat here.
Yeah, that sounds great. Either way.
And while people are thinking, there was a question about whether this session would be made available. And yes, we'll be posting this on the eScience YouTube channel sometime in the coming week, if you want to review any of the information. We've clearly done an amazing job, Anissa.
Been doing it for 9 years, so. I will maybe answer one question that often comes up. Both students and project leads often ask if there is the potential to continue working on the projects at the end of the summer for the students to continue working with the project leads. And very often that happens. I will say there's no expectations. There is, the students have no obligation to continue working on the project, but there's often a will to do that. usually by the end of the summer, the teams have really gelled and have great working relationship. And so sometimes when we've worked with faculty members, the faculty have gone on to hire students as research assistants. In other cases, there's, more of a voluntary exchange of work. And so that it has often happened. And eScience will support the student travel to present the work at conferences or things like that. Even years later, we will provide funding to allow them to travel and do that kind of thing. Okay. We'll give another minute for any questions that come up. And if you think of questions later, my contact information is on the slide here. I'm happy to answer those questions. I'm also happy to connect you with our research staff if you have more questions of a more technical nature or are wondering about technical fit or anything.
There is one question that's just popped up about sub-projects being part of a larger project. Do you see that question, Anissa?
Uh-huh. Yeah. Yeah. So that is often the case. As I said, in 10 weeks, we don't expect that we are doing the work that is going to be the end all be all solution to some really complex social problem that's, longstanding. And so oftentimes we're collaborating with project leads who have a much larger, broader body of work, and what they're proposing for the summer is some subset of that work. And we actually really look favorably upon that, because it really, that's an important key to knowing that the work is sustainable and that it's going to continue on after the summer, and that the project lead will continue to develop it and work with it. I don't know if that is the question that you meant to ask, but yes, we welcome sub-projects that are part of a larger project. And we also will, if we get a proposal that looks really promising, but it's just like, okay, that's a little ambitious for our program, we're happy to have a conversation and figure out how do we, could we scope that down to something that is manageable for the 10 weeks? Or on the flip side, sometimes we get a project and we look at it and we say, well, that's something, we have 4 really, really bright students who are going to be working on this team. We think they could probably get that done in 4 weeks, not 10. So, let's go back to the project lead and talk about what other directions they might want to take the work in and expand it out. Okay, well, it sounds like though we've gotten all the questions, unless anything has come in the last second. So thank you so much for your time and attention. We really appreciate everybody being here and are really looking forward to reading your project proposals. And please do feel free to reach out if you have any questions in the meantime, or if we can help in any way.